I want to show one more example in this podcast here. We want to look at a situation where we find the force of friction in terms of just the variables. I call this type of problem alphabet soup. And on the AP exam, for the AP students, a lot of times the multiple choice section, which you're not allowed to use a calculator for, will give you a problem like this, and you've got to do a quick calculation just to get a particular answer in terms of a particular set of givens. So we've got a person pulling on a box using a rope. The tension in the rope is given as T, the box mass is M, and you're pulling at a certain angle theta. There is going to be friction in this situation, and so the coefficient of kinetic friction, because we're sliding at this point, we'll just call it mu. So find the force of friction in terms of these given variables, T, mu, theta, M, and you're also allowed to use constants like G. Any universal constant that appears on the reference table you can use in these types of problems as well, because they're constant. Well, it's a force problem, and we still do all force problems using free body diagrams. We're going to have normal force going up, weight goes straight down, friction is going to work against the way you're pulling, and then we're pulling at an angle with respect to the axis here. So our free body diagram is going to look like that. Now, we want to know the force of friction, and so I'm going to go ahead and start by writing my x direction, and we can say that F net equals m times a, and what we can say is that T1 times the cosine of theta, because again, if I'm working horizontally, I'm going to get a component that is adjacent to the angle, so I got to use cosine, minus friction equals m times a. Well, that's going to mean that T times the cosine of theta minus MA equals F. Now here's the thing. I've got an expression for friction, but look at my original question. Does it tell me if I'm at constant speed? Does it tell me if I'm accelerating? It doesn't. And so even though this follows our rules, notice that we kind of hit a dead end here. Let's see if we can look in the y direction to work on expressions in terms of just these variables. We'll say that in the y direction, F net equals 0, because we're not moving up or down. From a vertical standpoint, this box is stationary. All the motion's horizontally speaking. Well, if I look at my vertical forces, and again, I'm working in a standard frame of reference, and I actually that's a no-no there. I just worked on that assumption for the x direction. Upward forces would be normal force. The vertical component of the tension is going to be opposite to theta, so that's going to be plus because it points upward, and because the component is opposite to theta, that's going to be sine theta, and then minus mg equals 0. Now as I look at my variables, I notice what I can do here is I can say that the normal force equals, I can bring mg to the other side and make it positive. I can bring t sine theta to the other side and now make it negative. Okay? If I use the y side of my equation, I get an expression from the normal force. And since friction equals mu times the normal force, I can take this expression for normal force and say that friction is mu times mg minus t sine theta. And that is an expression for friction in terms of just the variables that I'm allowed to use. In the beginning, we saw the x direction was a little bit of a dead end, but we can always write our equations. On the multiple choice section of the AP exam, you're under a time limit. And so what you'd have to do is realize that the x direction is going to be a dead end, the y direction is going to be where you want to be, and kind of have that plan of attack. So for the purpose of this tutorial, we've showed you the whole thing, but all you really needed to do was this part here.